Okay, good morning once again. Please try and wake those that are still sleeping. Wake them up. Still remaining 2 minutes. Try and wake them. Okay, yeah. This morning we'll be talking about exponential functions. Exponential functions. How does this exponential functions looks like? First, then I'm going to teach you how to differentiate exponential functions direct and also how to use substitution and differentiate exponential function. Please like and invite others who are here to be here. It's okay. So let's proceed. Exponential functions are of this form when we have y equals to exponential x. Exponential x. We call these exponential functions. Is that clear? Sometimes you will see them y equals to exponential t square. Y equals to sometimes you will see exponential sine 2 theta. Y equals to exponential 3x squared plus 1. Sometimes you will see y equals to exponential minus x cos x. Sometimes you will see y equals to exponential tan x. And sometimes you come across functions of this form exponential in x. Yeah. So these are what? Exponential functions. So whenever you come across functions like this, sometimes you may see y equals to exponential minus st. These are exponential functions. You will see functions of this form. Y equals to exponential minus open bracket s plus at. These are exponential functions. Do you agree with me? Hope you are following. These are exponential functions. Okay? Yeah. So far, so good. Please invite others to be here. So far, so good. Let us now go ahead to differentiate exponential functions. Is that clear? Let's go ahead to differentiate exponential functions. Okay. Yeah. So now, assuming you are asked example, if y is equals to exponential x, now say find y prime. Amen. So if we want to differentiate functions of this one, the simple as ABC, as the right solution, y is equals to exponential x. Let me open your eyes, both in the spirits and physical, mathematically. What do you have here? X, right? So within you now write x aside, just within you. So you differentiate what is here. If you differentiate x, note that we have invisible one here, right? If you differentiate this x, you are going to use this one to multiply whatever that is here, true or false. So 1 times x raised to the power of 1 minus 1, true or false. So this implies that this is the same thing as 1 times x raised to 1 minus 1 raised to the power what? 0, true or false. So equals 1 times anything raised to the power 0 is what? 1. So 1 times 1 is 1. So use this 1 to multiply back this function, this exponential what? X. So our dy all over the x is equals to 1 times exponential x. So the final answer will be what? Exponential x. Do you understand? Please ask question. If you have any question, drop your question in the comment section. Any question? Is there any question? Please, or we should proceed. Do you have any question? Morning, Ahmed. Nasir Ahmed, you are just coming. Oh, you don't understand. Abubakar, you don't understand? Okay, let me take it again. Okay, now, they said this is an exponential function, true or false. So now they said if y equals exponential x, find y prime. So now your y prime now be equals to what is on top of the exponential? What is here? Is it not x? So I now said within you now differentiate what is here within you. Is that clear? Using your mindset. So if you differentiate x, mind you, already we have here what? We all know how to differentiate, true or false? It is. So use this one to multiply whatever the coefficient here. So this will now be 1 times x raised to the powers of what? 1 minus 1. True or false? Yeah. So this will now be equals 1 times x raised to the power 1 minus 1 is 0. And in indices, anything raised to the power 0 is what? Is 1. So this will now be 1 times, here will be 1, which is equals to 1 times 1 is 1, true or false. So now you use this answer to multiply this function, all of this. Do you understand? That is your answer. So your y prime will now be, what is here? 1 times exponential x. This is the same thing as exponential what? X. Are you clear? Are you clear? Okay, so we can proceed, right? It's okay. So let's proceed further to consider more examples. Okay. Given y, now say find y prime. Okay, so we now write solution y is equals to exponential 2x. So now, if you want to differentiate this exponential function, what will first come into your mind? You always consider what is on top the exponential function. What is there? 2x, right? So within you differentiate 2x. If you differentiate 2x, you are going to have 2. True or false? It's true, right? So use this answer to multiply this. So it means our y prime is equals to what? What is there? 2 times whole of this function. So 2 and our y prime equals to what? 2 exponential 2x. Is this difficult? Look at it. Any question? Any question? Yes or no? Mubarak Musa, A18. You are just coming. Any question? No question? Please keep liking. No question. Can we proceed? Okay. Mubarak said no question, so it means everybody is following, right? Except for those that are just coming. Okay. So let us proceed. Okay, what if now we said find y prime and y prime prime? It means we have to differentiate this function twice. So for us to obtain y prime prime, we'll differentiate this. What we'll consider is we'll differentiate y prime to obtain our y prime. So we have 2 exponential 2x. So what you should consider is still the same thing, just within you, what is top the exponential 2x, true or false? 2x. So if you differentiate 2x, you get 2. Then use this 2 to multiply what is here. So it means the answer here is 2 times 2 exponential 2x. True or false? So our y prime prime will now be equals to 2 times 2 is 4 exponential 2x. Do you understand? So if you understand this, okay, I want you people to differentiate y prime prime. Find y prime prime. What is the answer? Please drop it in the comment section. I'll give you 1 mark. Please, your time has started. I give you only 2 minutes. Find y prime prime. I give you only 2 minutes. So y prime prime will be equals to what? Type the answer. The first 5 students, I'm going to give you 1 mark each. You remind me in class. Your time is going. Find y prime prime. y prime prime. Is it 6 exponential 2x? No. Mubarak, you failed. Yeah, Peter, Kenneth, you got it. That is nice. Peter, Kenneth, remind me, you got the answer. And who again? World code, you got it. Okay. Abubakar Sadiq, you did not write the 2x. You failed it. Okay, I think it's only Peter, because for us to obtain this, we have to differentiate exponential y prime prime. So what we are going to consider here is what? 2x, right? So if we differentiate 2x, we'll get 2. Then use this 2 to multiply 4 exponential 2x. So 2 times 4 exponential 2x. So our y prime 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 will now be equals to 2 times 4, 8. 8 exponential what? 2x. True or false? So those that did not get it, please, I want you guys to find IV. Find IV. Oh yeah, I give you 2 minutes. Use this y prime prime to obtain IV. What is the answer? You don't need to even solve. What is the answer? Peter, congratulations. Peter has gotten the answer. Yeah. 6 exponential 2x. Congratulations. Peter, remind me in class. It's okay. Yeah. So for us to get our y IV, it means we differentiate 2x. Any answer is to multiply. So when we differentiate 2x, we are going to have 2. So use this 2 to multiply 8 exponential 2x. Here will be 2 times 8 exponential 2x. So yiv is equal to what? 16 exponential 2x. Any question, please, before we proceed further? Any question? Nasiru Ahmed is not just 16 exponential. You've forgotten the 2x. Any question? No question. So we can proceed, right? Okay. Let's proceed. Let us proceed. Let us proceed. Let us proceed. It means everybody is following, right? Everybody is following. Okay. Yeah. So this is how to differentiate exponential functions. Direct. Okay, yeah. So let us proceed. Given y equals to exponential tan 2 theta, then now say find y all over the theta. It's simple as ABC. Let us write solution. y is equals to exponential tan 2 theta. Yeah. So if you can see what I am saying, you don't need a prophet to tell you. After the exponential, what do you have? Tan 2 theta. So what you need to do within you differentiate tan 2 theta, two of us. Your rough work, then any answer, use it to multiply this function. So I think I've taught you how to differentiate tan 2 theta or tan 2x. So who can tell us the answer? If you can tell us the answer, I'm going to give you 2 marks. And I give you 2 minutes to do that. I'm waiting, please. Yeah, Peter, I want you to get the final answer. We know that no, you did not get it right. Your answer is wrong. Solve it again. Peter. Okay, Mubarak. Usman. Yes. Then use it to multiply the function now. Mubarak, you're almost there. You're almost there. Mubarak. Usman. You're almost there. Yeah. This person, Abubakar. I love that. Abubakar, I'll give you 2 marks. You're right. Yeah. We all know that whenever we differentiate tan 2 theta, we are supposed to have what? 2 sec square what? 2 theta, right? 2 of us. So we have to, this is the answer. Use this answer to multiply this function. Isn't it? It is. Right? So it means our dy all over the theta is equals to 2 sec square 2 theta times the exponential, 2 of us, times the exponential tan 2 theta. So the final answer will now be dy all over the theta is equals to 2 sec square 2 theta exponential tan 2 theta. True or false? True or false? Look at the board. Is there any question? Any question? Any question? Yes or no? Please try and invite others. Sir, I don't understand Musa Abubakar because you are just coming. Anyway, I will still explain to you. I know you are just coming. So, somebody is still complaining that he doesn't understand. Okay, so let me clean it again. I know that that person is just coming. Clean it again and demonstrate how we are able to get the answer. I'm here because of you guys, who I must explain again and again. Okay. Again and again. Oh. Board is wet. Okay. Yeah, so just listen. These are exponential functions. So whenever you come across exponential functions of this form, exponential tan 2 theta, what you should consider is just concentrate on what is on top the exponential just after this. So within you take this, what is there, tan 2 theta, to your rough book, then differentiate it, tan 2 theta. If you differentiate tan 2 theta, or ordinarily if you differentiate tan theta, what is supposed to have? Is it not sec square theta? Yeah, but if you differentiate tan 2 theta, you are going to have 2 sec square 2 theta. This is what you are supposed to get. Are you following? So now, you now use this answer to multiply this function. That is the whole of this function. That is your answer. Is that clear? So now our dy all over the theta will now be equals to, what is there? 2 sec square 2 theta. Use it to multiply this. That is 2 sec square 2 theta times exponential tan 2 theta. True or false? So now the final answer will now be, the theta is equals to 2 sec square 2 theta exponential tan 2 theta. This is the answer. Obaka, are you following? This is the answer. So, any question? Any other question? Okay. So let's proceed. Let us proceed. Order to consider more examples. But okay. So now, given y equals to exponential 2x squared plus 1. Amen? Yeah. So what we need to do is write solution y is equals to exponential 2x squared plus 1. Who has finished solving? Yeah, I want you to solve this one and tell us the answer. Tell me the answer, rather. Who is done? Who has finished solving? Who has finished solving? Peter. Okay. No. Mubarak. You not got the answer. You not get it. Solve it again. Peter, are you here? Peter, solve this one. Aminu, solve it. Red one, Ahmed, solve it. Okay, 2x. Yeah. Aminu, Bala, you got it. That is nice. Congratulations. You got it. It's okay. So let's proceed. Let us proceed. So it means, fine, I did not write fine dy over dx. So it means within you write down 2x squared plus 1, right? Okay. So when we differentiate already, this is 0. We differentiate 2x squared, you are going to have 4x, two of us. We are using to multiply this. So you are going to have dy all over the x is equals to 4x times exponential 2x squared plus 1. Then the final answer will now be dy over dx is equals to 4x exponential 2x squared plus 1. Yeah. Any question, please? Any question? Do you have any question? No question. So let us proceed, right? It's okay. So let's proceed. Let us proceed to consider more examples. Amen. Let's proceed to consider more examples. Okay. Yeah. Let's look at this. If y equals to exponential minus x cos x, find y all over the x. Yeah. As simple as ABC. We write solution y is equals to exponential minus x cos x. If you look at this question critically, you will see that I just added something. Who can tell us? I added another function again. Can you see now? Minus x cos x. It means here we have two functions multiplying each other, two of us. Yeah. So what will first come into your mind? We have to apply product rule, isn't it? True or false? To differentiate this function. But the product rule may not be necessary. Because they did not specify. They always say y equals to this. So you can differentiate these functions direct. True or false? So let's go ahead to write it down, minus x cos x, right? So we either differentiate minus x whole cos x constant, then any answer, okay. So if we differentiate minus x, we are going to have minus 1 used to multiply times cos x, then plus whole minus x, then differentiate cos x. We are going to have minus what? Minus x, isn't it? Yeah, minus sine x. So you are going to have minus sine x. I know some of you are confused. Okay, so this minus 1 times cos x minus cos x, then minus times minus plus. So x times sine x plus x sine x. Or this is, we can rewrite this in this form, x sine x minus cos x. This is the same thing as this. So which one do you want us to take? Either this one or this one, any one. So our dy all over dx is equals to x sine x minus cos x. Use it to multiply the function back. So this is what we are going to have, exponential minus x cos sine x. Please, any question, look at the board, ask your question, drop it in the comment section. Drop your question in the comment section. Any question? Any question? Oh, yeah, cool. I should take it all over. Not understand. It's okay. Let me take it all over again. Now, when you come across functions like this, you know that if we have, let us say, x cos x, you know that we are supposed to use quotient rule. Product rule. True or false? Because this is another function and this is another function. So two functions multiplying each other. So you don't need a prophet to tell you that if you write this function as within you minus x cos x. So if you want to differentiate these functions direct, is that clear? Without using product rule, what you need to do is, or should we use the product rule? Okay, let's use the product rule. Our product rule, I think that will be more understandable for you guys. Y equals to uv, so our dy all over the x is equals to the v du all over the x plus u dv all over the x, right? So we now say let u equals to minus x and v equals to cos x, true or false? So our du all over the x is going to give us minus 1. Then our dv all over the x is going to give us minus sine x, isn't it? So what we need to do, we substitute this into this formula. Here will be dy all over the x is equals to our ordinary u, v is cos x times du all over the x is minus 1. Then plus our ordinary u is minus x times our dv all over the x is minus, is it not the same thing? Yeah. So if you can see what I am saying, this is the same thing as minus 1 times cos x is minus cos x, minus times minus plus x sine x, isn't it? It's the same thing. So the final answer will now be the x all over the y all over the x, is equals to use this answer to multiply back the function. So here will be, or I told you, if not like this, or this is the same thing as the y all over the x is equals to, first write x sine x, x sine x minus cos what? X is the same thing. So x sine x minus cos x times exponential minus x cos x. This is what you are supposed to get. Is that clear? Do you understand? Either you use the product rule direct, or you use a direct approach. Is that clear? Okay, let's proceed further to consider exponential functions using substitution. Because that is what going to, even if to set at all. There's a duster. Even if I'm to set, that is what I will love. I will ask you people in exam, as I will not just say this, that, fine. I will only say use substitution to obtain dy all over the x. So please, I want you to listen what you want to do now. I want you to listen what you want to do now. What you want to do now. What you want to do now. I want you to listen. Okay? I want you to listen attentively. Okay. using substitution, right? Method. Using substitution method. So now we want to use substitution. If y is equals to exponential tan 3x, find dy all over the x. Is that clear? So now they said you should use substitution. This is what you are going to do. We write solution y is equals to exponential tan 3x. What I will tell you, you go back to your chain rule. Is that clear? It's the same approach that we are going to use if you can remember your chain rule. Amen? Yeah. So we'll now see. Let any alphabet, either P or U, be equals to what is on top the exponential. What is on top of the exponential is what? Tan 3x, true or false? Tan 3x. Then this means that your y will now be equals to exponential what? P, isn't it? Exponential P. So we have to what? Differentiate tan 3x, then differentiate exponential P. Is that clear? So when we differentiate this function, dp all over the x, this will going to give us what? 3 sec square 3x. True or false? It's true. Then when we differentiate y equals exponential p, is the same thing, because our dy all over the p is going to give us exponential p again. Because if you differentiate p is 1, use it to multiply back the exponential, is the same thing. True or false? So therefore, our chain rule will now be the y all over the x is equals to the y all over the p times the p all over the x. Which is our dy all over the x is equals to, what is dy all over the p? The y all over the p is exponential p times the p all over the x is 3 sec square 3x, right? But our p is what? Tan 3x. So the final answer will now be our dy all over the x is equals to, we write this one before the exponential, 3 sec square 3x exponential, you put it inside the bracket, no problem, exponential tan what? Tan 3x. This is the final answer. Do you understand? Any question? This is how to use the substitution method. So in the exam, you should expect this. Use the substitution methods to obtain dy all over the x. So do you have any question? Please ask before we proceed. Any question? Yes or no? Or we should proceed. Amen. So let us proceed. As long as you understand your chain rule, I don't think this will give you a problem. Okay, so let's move further to consider questions like this. Okay, another example, given y equals to exponential 3x raised to power 4 plus 2x squared plus 1. Now say find dy all over dx. They said we should use substitution, two of us. So let's write solution. Y is equals to exponential 3x raised to power 4 plus 2x squared plus 1. So we now say let u or any alphabet be equals to what is here? 3x raised to power 4 plus 2x squared plus 1, right? Okay. Then our y will now be equals to exponential what? U. So let's differentiate this function with respect to x. So it implies that the u all over the x, we are going to have what? 12x raised to power 3 plus 4x, isn't it? This is 0. True or false? Then differentiate this, our dy all over du, isn't it? Is equals to the same thing, exponential u. Then our product rule will now be dy all over, chain rule will now be dy all over dx is equals to dy all over du times du all over dx. So dy all over dx is equals to, what is dy all over du? Exponential what? Exponential u times du all over dx is 12x raised to power 3 plus 4x. Then what is our u? Our u is this. So we write this one first, or we leave it like this, whichever way you are right. Our dy all over dx is equals to 12x raised to power 3 plus 4x, all in brackets, times exponential, our u is this, 3x raised to power 4 plus 2x squared plus 1. This is the final answer. Any question, please look at the board. Is there any question? Is there any question? Do you have any question? Any question, please ask. Any question, or we should proceed? We should just proceed. Any question, yes or no? No question? Okay, if there is no question, let us proceed. Let's proceed. Let us proceed. There is no question. Let us proceed. It means everybody is following. That's nice. Okay. Yeah. Okay, what if we now have if y equals to exponential x plus 1 all is square? Yeah, it's a very good question. We have to use what? Substitution. So this implies that y is equals to exponential x plus 1 all in what? Square. So what are you going to do? We now say let u be equals to what is inside the bracket, right? X plus 1. Then it means your y will be equals to what? Exponential u raised to the power of what? 2. So the u all over the x is equals to 1. Then our dy all over the u are going to give us what? 2u exponential u squared. True or false? Because if you differentiate u squared, you are supposed to have 2u, then you need to multiply the function. So 2u exponential u squared. So our chain rule will now be the y all over the x is equals to the y all over the u times the u all over the x. So for so good, the y all over the x is equals to what is the y all over the x? 2u exponential u squared times the u all over the x is what? 1. Amen. Then what is our u? Anywhere you see u, you substitute in this. So our dy all over the x is equals to what? 2 open bracket x plus 1. Then exponential, because 1 times this is the same thing. Exponential x plus 1 all in what? Square. This is our final answer. Any question? Please, do you have any question? I think these are the types of questions you should expect in your exam. Yeah. Any question? No question? No question. Okay, let's solve another problem. Then I'm going to drop assignment. It means on Monday all of you are submitting. Try and inform others who are not here. Let's look at another problem. Given y equals to 2 exponential x minus 1 raised to the power of 3. Find dy all over the x using substitution method. So far so good. Let's write solution. Y is equals to 2 exponential open bracket x minus 1 raised to the power of 3. What are we going to do? We now say let u be equals to x minus 1. Then y will be equals to 2 exponential u raised to the power of what? 3, right? So let's differentiate our du all over dx is equals to 1. Then, when we differentiate u raised to the power 3, we are supposed to have 3u raised to the power 2. Then use it to multiply the function. It implies that our dy all over du is equals to 3u times 2 exponential this. We are going to have 6u squared exponential u raised to the power of 3. True or false? Then our product to chain rule now with y all over the x is equals to the y all over the u times the u all over what? The x. So our dy all over the x is equals, what is dy all over the u is this 6u squared exponential u raised to the power of 3 times du all over the x is 1 times 1. And what is our u? Our u is this. So our dy all over the x is equals to 6 open bracket x minus 1 all in what? Square exponential what? U is x minus 1 raised to the power of 3 times 1 is the same thing, so it is not necessary. So this is the final answer. Any question before I write down the assignment? Do you have any question, please? Any question? No question? Okay. So if there is no question, your assignments to be submitted on Monday. Assignments given y equals to exponential all over 3 x plus 1 cube root of this. Then find the y all over the x. This is your assignment. Take notes. Is that clear? This is your assignment. Please write it down. Make sure you write your assignment inside a piece of paper. Write all your details. I'll be coming to collect your assignment. No excuse. You have today, tomorrow to do your assignment. So please, thank you for your time. Don't forget to like and share. Love you guys. Bye. Yeah. You are going to use substitution, not direct approach. Use substitution, please.